Then let we start. In this video I will explain the solution of the final term exam. We have in the first exercise a reaction between permanganate ion and the sulfur dioxide that is found in polluted water. We prepare a solution S of potassium permanganate of volume 200 milliliter and concentration of 0.2 mole per liter. The question is determine or calculate the mass of potassium hydrated potassium permanganate needed to prepare this solution. We have the molar mass of potassium permanganate. Isn't to calculate the mass by using the equation or the formula mass equal N times molar mass. Okay, N mass equal N times the molar mass, well N is equal to C times V. So we substitute the concentration 0.2, volume 0.2, and the molar mass is 158. So the mass of the dissolved quantity of potassium permanganate is 6.32 gram. The second part in this exercise about the kinetic study of the reaction between potassium permanganate. Isn't we prepare 4 mixtures in 4 beakers. Each beaker contain, let's look about that we have each beaker contain 20 milliliter of S. This is the volume of solution as used in this experiment in order to find or to study the kinetic of this reaction. And 80 milliliter of polluted water. This is the volume of water that containing sulfur dioxide. This is the volume of water that containing sulfur dioxide, 80 milliliter. Isn't in a beaker we add 20 milliliter of S and 80 milliliter of polluted water. Isn't at different instant each beaker is placed in ice water. Isn't after a certain period of time, we place each beaker in ice water bath. Then we measure the pH of the mixture. And the results are given in the following table. Part 1 shows that at an instant time t, the number of mole of permanganate ions are expressed by the following equation. Then we want to verify the following relation between the number of mole of potassium permanganate and the pH of the solution obtained at different instant of time. Is to write or to find the relation why we apply the stoichiometric ratio. According to stoichiometric ratio, number of molar potassium permanganate over 2 equal number of molar H3O plus. Since we need to find a relation between N of permanganate and pH, is an pH it is about the ionic species H3O plus. فإذا أنا لأن بدي relation between permanganate ion and pH will pH يعني is related to the chemical species H3O plus. So number of mole of permanganate according to stoichiometric ratio equal N lal H3 over 2 by eliminating 2 and 2 from the coefficient. This is the number of mole of permanganate that is react. Number of mole that is react. Okay, which is equal N initial minus N we here left at a time t. This represent the number of mole of permanganate ion that is left or remained at a different instant of time. And N initially, how we calculate the initial quantity number of mole in خلال C times V, with C minus 0.2 and the volume is 20 milliliter. هون أنا كان معي بالسؤال 20 milliliter which is 0.02. We obtain a number of mole 0.004 mole. Okay, we replace the number of mole of H3O plus by C times V. As we know, the concentration of an acidic solution, the concentration of acidic solution is C for acidic solution is equal to 10 power minus pH. We replace the concentration of C by 10 to power minus pH with volume. Why it is equal to 0.1? لأنه we have an H3 أو H3O plus is a product. The H3O plus is a product. The H3O plus is a product. So we take V total. We take the V total. With V total هو عبارة عن 20 plus 80 milliliter. In the exercise as we have 20 milliliter of solution S and 80 milliliter of polluted water. Here we obtain the V total for H3O plus ion that is produced at an instant time. 20 plus 80 is equal to 100 milliliter, which is equal to 0.1. So we replace the volume. Then we can obtain the following relation. A number of mole is equal to 4. I will explain here how I write it. Number of mole H3O plus is equal to C times V. 10 to power minus pH times the volume 0.1. When number of mole permanganate ion that react is equal N initial minus N at a time T, which equals 0.004 minus number of mole of permanganate ion at any time T. So number of mole of permanganate ion at any time T is equal 0.004 minus the number of mole of permanganate ion that react, and this is equal, by using stoichiometric ratio, is equal N of H3O plus over 2, which is equal 0.1 times 10 to power minus pH over 2. If we replace it in the relation, number of mole of permanganate ion at any time T equal 0.004 minus يطلع عندي 5 times 10 to power minus 2 ضرب 10 to power minus pH. If I take a common factor 10 power minus 2, we obtain the relation 0.4 minus 5 10 to power minus pH times 10 to power minus 2. This is the relation which is verified, or we want to prove it in this exam. Okay. In the second part, copy and complete the following table. After we prove the above relation, we use the above relation to complete the table. The values are as following. We have the pH, we substitute the pH, we obtain the following number of mole, and we have the value of number of mole of permanganate is equal to 0, and we apply and we can calculate the pH of the solution. By using the above relation, we found the following relation, or we complete the following table. The third part, determine the half-life. To determine the half-life of the reaction, دايما بس تسأل عن the half-life, I write the definition of the half-life. The definition of the half-life is the time needed for the limiting reactant to be half its initial quantity. إذا أنا هون علي أعرف which reactant is a limiting reactant, is the permanganate or sulfur dioxide. إذا بتطلع بالتابل هون كان أنا عندي الفكرة. In this table, the number of mole of permanganate ion is totally consumed is equal to 0. Is equal to 0 يعني totally consumed. Totally consumed يعني nothing remains. So it is a limiting reactant. So potassium permanganate is a limiting reactant. So at T half, number of mole initially is equal to 0. هذا هو number of mole initially in the mixture 0.004 or 0.4 or 4 millimole. We divided it by 2, so we have 2 millimole. 2 millimole at T half is equal 4 minutes. This is the T half. This is the quantity of the potassium permanganate at the half life. إذا بهالشكل هي التريك فيها إنه we must deduce the limiting reactant. To calculate the average rate in part 4, to calculate the average rate of the disappearance, نحن بنعرف إنه rate of disappearance is equal to minus، لأنه هذا reactant، minus delta N over delta T. minus delta N، minus هذا reactant minus delta N. نعمل substitution N هي minus the number of mole at T2 minus the number of mole at T1 over T2 minus T1. We apply the relation number of mole at between 4 1 minute. إذا لأنه I ask about the average rate between 1 and 4 minutes. We substitute the value of number of mole and we calculate the value with number of mole. Our rate will be is equal to 0.3 millimole per minute. Some note in this exercise: when we calculate a number of mole to complete the table, when we use the above relation, when we calculate the number of mole of permanganate ion from the above relation 0.4 minus 5 times 10 to power minus pH times 10 to power minus 2, if we substitute any value of pH by on the calculator, we obtain the number of mole as a power of 10 power minus 3. على الكالكوليتر هيطلع معكم 10 to power minus 3. لأنه التيبل أنا بالتيبل في عندي بدي number of mole in table must be in millimole, the number of mole in table must be substituted in millimole. وهون كان في عندي أنا كتير بالطلاب غلطوا فيها. أنا هتحول من المول للمليمول، من المول للمليمول حتى أعمل conversion. أنا هيدي يعني معناتها بدي أضرب هذا الرقم this value اللي طلع معي بدي أضربه من المول للمليمول، بدي أضربه ب1000. لما أضرب ب1000 هيدي مع هاي بتروح فبيطلع بس الجواب هو اللي بيكون مكتوب هون. يعني أنا مثلا at t equal to 4 minutes for example, the answer on the calculator the number of mole is equal approximately ل 2 times 10 to power minus 3 mole. To change into millimole times 1000 بضرب ب1000 بيطلع عندي أنا 2 ملي مول. إذا بالبارت 4 control اللي choose the correct answer with justification 2.5. The relation between the average rate the average rate of disappearance of sulfur dioxide is R prime and the average rate of disappearance of permanganate ion is. نختار the correct relation between the average rate of disappearance of sulfur dioxide and the rate of disappearance of permanganate. هون نستعمل نحن ال stoichiometric ratio. By using stoichiometric ratio I calculate the average rate. والstoichiometric ratio من خلال stoichiometric ratio rate of permanganate ion over 2 equal rate of sulfur dioxide over 5. So rate of sulfur dioxide is equal 5 over 2 rate of permanganate ion. So the correct answer is B. Calculate the concentration of sulfur dioxide in polluted water. To calculate the concentration of sulfur dioxide in polluted water, I calculate it as following. By using stoichiometric ratio, since the permanganate is a limiting reactant, by using stoichiometric ratio, we substitute the value number of mole initially للبرمنجانيت اللي هي كانت 0.004 يطلع عندي number of mole of sulfur dioxide is equal to 0.01. To find the concentration, divide by V, where volume of the polluted water is 80 milliliter or 0.08. أخذت 80 ملي لأنه هذا ال quantity of sulfur dioxide is that is added initially in the beaker. So we calculate the concentration of sulfur dioxide in polluted. Okay. The third part in this exercise is about the kinetic factor, about the study of kinetic factor, and we have two experiments is done. The first experiment, if we notice that in the first and the second experiment we have the same quantity of potassium permanganate, same volume, same concentration, nothing can change. The quantity of potassium permanganate remain constant, whereas the quantity of polluted water in experiment 1 is equal to 0.125, which is calculated in the previous part. In experiment 2 it become we have the concentration of polluted water is 0.2 mole per liter. Even so, concentration of sulfur dioxide in water is increased. We have different rate of the reaction. We have the concentration of manganese ion or N2 plus at the end of the reaction. In the first experiment he is equal to 4. Then in the second experiment is unknown. For each statement justify if it is true or false. إذا لما يكون عندي هيك سؤال بدي أحدد أنا إذا كانت الجملة صح أو خطأ، بدي اشرح ليش هي خطأ. We must justify the following statement if it is true or not. The first statement: the rate of the reaction R prime is less than R. إذا is the rate of the reaction in experiment 2 less than R experiment 1 or not. According to the variation in the concentration of polluted water. بنلاحظ إن concentration of polluted water or sulfur dioxide in polluted water is more in experiment 2 is more than in 1, and we know that the concentration is a kinetic factor. Concentration is a kinetic factor. As the concentration increase, the rate increase. So إذا in this exercise بنقول له أنا أول شيء بقول له عندي same quantity. بقول له what is the similarity between experiment 1 experiment 2 and the same quantity of potassium permanganate, ولكن the concentration of sulfur dioxide is increases. So and this concentration is a kinetic factor. هذه لازم أذكرها أنا بالامتحان إنه kinetic factor، والمقصود بالkinetic factor يعني as the concentration increases the rate of the reaction increase. So this statement is false. For the second statement, it's about the concentration of Mn2 plus at the end of the reaction of experiment 2 is equal. We want to calculate if this value is correct or not. We want to determine if this value is correct or not. It might be 6.4 greater than, more than in experiment 1. هل الرياction 2 will produces more Mn2 plus substance or not. Since the quantity of permanganate ion remain constant, where permanganate is a limiting reactant. In experiment 1 it is a limiting reactant. Since the quantity of limiting reactant doesn't change, remains the same, same volume, same concentration, same number of mole. So the quantity of the product is not affected. The quantity of the product is not affected since the quantity of the limiting reactant doesn't change. بما إنه the number of mole of limiting reactant does not change, so the quantity of product obtained is not change, will remain the same. So the statement is false. Okay, the second exercise is about the acidic solution HA. We have the following materials. Glassware is given. We have a bottle of commercial strong monoacid H8. إذا في عندي commercial solution of strong monoacid H8 percent by mass is 21%. The density of the solution 1.2 gram per milliliter. The molar mass 63. Okay, part 1 about the preparation of the solution S. We prepare from a commercial solution S. We prepare 100 milliliter, 250 milliliter of solution S that is diluted 50 times. Isn't we prepare a diluted solution 250 milliliter diluted 50 times. Specify the glassware. Specify the glassware. We have dilution. In dilution, the glassware must be volumetric, flask, and pipette. We want to determine what is the type of pipette used. اوكي اذا اكيد لما يكون عندي هيك اسئله انا بدي اقوله دائما يكون عندي dilution بتقول له during number of mole of solute is conserved. بدي اركز لازم نكتب بالامتحانات number of mole of solute. هيدي عليها خصم ربع عليه بالامتحانات الرسمي. So dilution factor V1 over V0. We calculate V0 هيطلع 5 milliliter. So according to the glassware given or the list of glassware given in this exercise, we choose 5 milliliter volumetric pipette and 250 milliliter volumetric flask. Second part is about the procedure. هيدي بتكون حفظ as it explained in the classroom. In part 3, I'll choose the material that other than the glassware. The material other than glassware are pH meter, magnetic stirrer, and magnet bar. إذا أنا بعد بحتاج لهم بالtitration. بالtitration other than the glassware في عندي 3 materials that are mentioned in the list. هن pH meter, magnet stirrer, and magnet bar. The third part it is about explain why we can't use titrate. Why we can't titrate 25 milliliter of commercial acidic solution by sodium hydroxide instead of solution S. يعني إذا بطلع أنا هون قلب أنا بالtitration we use 25 milliliter of solution S اللي هو أنا عندي diluted. هذا كان diluted solution. هذا diluted solution. The diluted solution we take 18 milliliter needed to titrate this dilute solution 18 milliliter of sodium hydroxide. إذن why we can't use in titration a commercial solution? Why we don't titrate a commercial solution? السبب لأنه the commercial solution is more concentrated solution. يعني it will need very large amount of titrant اللي هو الصوديوم هيدروكسيد. هلا بعمليه حسابيه بسيطه اذا انا الديليوتد سوليوشن اخذ 18 ملليلتر اوف صوديوم هيدروكسيد. طب انا الكوميرشال سوليوشن هو مور عنده يعني هو مور كونسنتريتد باي 50 تايمز. يعني عنده الكونسنتريشن له اكثر من 50 بالمره 50 مره. يعني هو مور كونسنتريتد باي 50 تايمز. يعني if I want to calculate what is the volume of titrant needed to titrate 25 milliliter يعني حيكون عندي 18 ضرب 50. يعني أنا تقريبا حيطلع أنا عندي حوالي 900 ملليلتر من 900 ملليلتر من الصوديوم هيدروكسيد. هذا اللي بحاجة إلى needed to titrate a 25 milliliter of concentrated or commercial solution. إذا لأنه commercial هو very concentrated solution more concentrated يعني it take a large amount of titrant or sodium hydroxide. إذا since it need a large amount of titrant. هلا in experiment in part 3 يعني student A uses 50 milliliter of beaker and 10 milliliter burette. Student B uses 100 milliliter beaker and 25 milliliter. Which student use the correct glassware؟ مين اللي حيستعمل glassware الأحسن أو الأصبح؟ هلا أنا بعملية حسابية بسيطة. أنا بما إنه أنا عم نستعمل 25 milliliter of solution S and we add it 10 milliliter of distilled water and then we add to this beaker during titration 18 milliliter of sodium hydroxide. So الفوليوم in the beaker لازم يكون if we to calculate what is the volume of the solution in the beaker, and 25 plus 10 plus 18 هذا حيطلع عندي approximately عندي 83 milliliter, which is greater than 50 milliliter. This capacity of beaker هو 50 milliliter. We can't use it, so the student B is the correct one by using 100 milliliter beaker. أو أنا فيني أقول لأنه we have another method عندي 18 milliliter of sodium hydroxide is added from the beer. بدي أزيد أنا من البيور 18 milliliter من الصوديوم هيدروكسيد. I can't use 10 milliliter burette, so I will choose a 25 milliliter. This is the answer of part 2-3. قال لي بعدين show that the concentration of the sodium hydroxide is a strong base. To show that, to verify if it is a strong base, we must prove the 14 plus log of concentration. لازم برهن انه 14 plus log of concentration is equal to pH. لازم هيك دايما انا ببلش بالامتحان انا شفت لا في كتير عم يكتبوا لي pH is equal to the concentration. عم يبلشوا في كتير بيقولوا pH is equal to 14 plus log of concentration of base وعم يعملوا substitution عم يطلع نفس الفاليو. لا هلا في البعض حط question mark اوكي بس ولكن بالامتحانات الرسميه هيدا حيبطلوها. فدايما انا بدي بلش بال 14 plus log of concentration of the base. نعمل substitution بدي بين انا substitution الفاليو قديش عم عوض بتطلع الفاليو and we compare it to the pH. If it is equal then it is a strong base. equation of titration هيدي دايما ثابته لا تتغير. equation of titration between strong acid and strong base هي H3O plus مع ال HO minus gave to H2O. في بعض الطلاب ما ذكروا الاثنين نسيوا يكتبوها يطلع equation is not balanced so it is 0. Okay. In order to calculate the concentration of the acid in the solution S دايما بتقول at equivalence point. في كتير من الطلاب ما استعملوا أو ببلشوا يقولوا at equivalence point at stoichiometric ratio. The number of mole of H3O plus in the beaker equal to number of mole لل HO minus added from the beaker. هدول لازم اكتبهم. هول لازم ينكتبوا. في كتير طلاب ما كتبتها هاي. إذا بتقول أنا كان عندي الآن الأسيد in the beaker بتقول هذا الأسيد in the beaker ل HO minus who is added from the beaker to reach the equivalence point. هول لازم ينذكروا. Then I say CAV equals CBVB at equivalence. We calculate the concentration. So the value will be 0.079. Okay. إذن the last part about the esterification reaction we take 0.2 mole of ethanoic acid. هذا number of mole معنى volume of propanol alcohol used. concentrated sulfuric acid عندي heating reflux is subject to heat reflux. قال لي at equilibrium 0.2 mole of acid remained. 0.2 mole of acid is remained with ester E is formed. Write the equation by using condensed structural formula. بدي اكتب condensed structural formula. اذا انا condensed الايثانويك acid هي CH3COOH وال2 بروبانول اللي هي CH3H CHOH CH3. دايما بدي اكتبها انها reversible equation if it is written only one direction 0 in the exam. إذا بيعطينا CH3COO بكتب هيدا أول بارت وبعدين أنا بدي كفي من عند الهيدروجين من هون بدي كفي مطرح هون في عندي CH بعدين CH3 و CH6 مرقينا أكثر من مرة بالشرح الدرس plus the other product is water. This is the esterification reaction. The name of the ester, systematic name of the ester. في عندي إذا عندي أنا هون 1 هيدي 2 على الرقم 1 أنا في عندي مثل فبقول كسيستماتيك نيم في عندي مثل إثل. هيدا الألكانويت هيدا اسمه إيثانويت. هذا systematic name of the ester octane. اللي shows that the initial mixture is equimolar. Equimolar same number of mole يعني أنا معنا الفوليوم للالكحول is given. اذا بنرجع given بالسؤال معنى الدنسيتي ومعنى المولر ماس. اذا من خلال number of mole is equal to mass على molar mass والmass هي density times volume. we substitute the value بيطلع 0.1 number of mole same number of mole of acid. حيكون نفس number of mole. ساعتها انا بدي اقول له the mixture is stoichiometric. بعد ما اعمل calculation بعمل comparison مع number of mole للاسيد. البارت اللي ورا هو عبارة عن قال لي calculate the equilibrium constant Kc. هون انا بدي اشتغل على التيبل of conversion. يعني اعمل calculation of Kc by using table of conversion. initially انا بحط at time 0. at time 0 انا معنى number of mole 0.2 اثنيناتهم equimolar. البرودكت 0 ب 0 اكيد minus x و minus x و x و x. فاذا بيطلع at equilibrium 0.2 minus x للاسيد والالكحول. النمبر الأستر هي x and x. بما انه انا we have أنا كان معي بالسؤال أنه أن للأسيد remained in the exercise is equal to 0.12. 0.12 يعني هذه كلها هي is equal to 0.12. إذا بدي أعمل calculation minus x فبيطلع معي x is equal to 0.8. بنعمل substitution بالكيسي. أكيد أنا بالكيس بدي أكتب الإكسبريشن أو الريليشن اللي إلها اللي هي بهالشكل. بدل الكونسنتريشن والان على في بدي ببين بالامتحان انه كاتب ان على في اور الفاليو النمبر اوف مول اوفر في. وبعدين بعمل elimination اوف في بشطبهم بعمل calculation اوف كيسي. اخر بارت بدنا انا percentile. to calculate the percentile هي an actual over an theoretical. an actual over an theoretical. اذا اللي بعمل بكتب الاكسبريشن an actual over an theoretical. هلا الاكتوال هو النمبر اوف مول ذات از produced. النمبر اوف مول ذات از produced at equilibrium هو 0.2 0.8. هون انا بدي يكون عندي calculation. هون عندي 0.8 عفوا 0.08. والان اوف استر theoretically بدي اقول له انا دائما بالامتحانات الرسميه بدي اقول له consider the reaction is complete. بما انه الميكس الرياكتنس ار equimolar معناتها انه ان stoichiometric ratio I use the stoichiometric ratio فبيطلع هذا الان theoretically هذا theoretical value بيطلع 0.2. بنعمل substitution بقلب البرسنتيل فهيطلع عندي 40%. البرسنتيل. This is the correction of the final term exam.